many of you do monitoring? Like how do you monitor your web apps in any way? Okay, everyone does, sure. That's fair enough. Alright, so how many of you do like system level monitoring? So CPU, RAM, stating the basics, pretty much everyone. And do you, how many of you do application level monitoring? How many of you know what it is? Okay, so a few less. Okay, this is essentially perfect. That's what the talk is about. So I'd be pretty curious to, I've been curious to learn that you have a somewhat active community here in Odessa. I understand there's a regular meetup here of like 50 or 60 Python programmers. You know, that's quite a big achievement actually. Like I organize events in the UK for Pythonistas and a big one in Brussels for general open source. And it's really hard to get people to show up regularly, so well done for getting people. In Cardiff, where I live, capital of Wales, where I lived for 5 years, we could barely get 20 people to show up, and half of them are students at the university. So you're already doing better than an entire other country, well, within the UK. So I like Ukraine's. I don't really know that much about the programming background here, and I'm doing with Python for over 5 years. Okay, so you got a few really long-term programmers. Okay, how about for over 3 years? Oh wow, okay, well, that's excellent. How many of you started using Python within the last year? Wow, that's amazing. That's like a perfect mixture. So you got, you know, intermediate people, you got a fair few juniors, and you got experts. That's like the event organizer's dream, like, because that's super useful. Then the juniors can learn from the more senior people. And I hope you do talk to each other. I'm not gonna make you turn to the person on the right and talk to them now, but you should go to the after party. You know, connecting together these events is what actually makes programming communities work. You go to work every day and you work with your 10 colleagues or whatever, but this is different. So I organize a conference that some of you may have heard of. I co-organize it, that's very big. Called FOSDEM. Has anyone heard of FOSDEM?
Yes.
Oh, one person! Ah, well, excellent. So you can learn about it. It's a free conference in Brussels. So there's no tickets, there is no registration. It's about 8,000 people. It's open source and free software hackers that gather together for a weekend, and there are talks on anything. Python is usually there, but there are about 20 to 30 like topics and rooms organized around those topics. You can learn about Postgres, you can learn about Internet of Things, blockchain, open source, whatever you want. It's sort of like a huge festival of open source and free software. So you're all very welcome. All you need to do is call yourselves to Brussels. And it's in the beginning of February, so I'm afraid you missed for this year, but perhaps next year. Yeah, I guess so. Yeah. I was waiting to get a slide for that, but I think we're quite far in the time. So, ooh! Right, so what I'm going to talk to you about very quickly now is application performance monitoring. So my name is Emanuil, or Emanuil. A lot of you can actually pronounce it, unlike people in the West. And I'm a community engineer, so my job is to go around and teach other engineers stuff that's useful in their day jobs for solving the problems that you will solve. I work in Elastic. Elastic makes Elasticsearch, which some of you may have heard of, makes Kibana, and a few other tools. Usually used for monitoring web apps, but also for search, like product search and advanced text search, Elasticsearch itself is open source, as are many of the other tools that my company makes. And that's sort of an overview of the whole stack. So Kibana is used for visualizing things, Elasticsearch is an open source search engine, and the other two things below are used to send information to Elasticsearch, so when you're doing monitoring. So APM is application performance monitoring, is a new thing that just got open source last year. So basically what happened is Elastic bought a company and then they open sourced 90% of their code. And they made the other 10% free to use, even for commercial settings. So it's not open source, but it is free to use. So the general idea with web apps, right? I mean, you get up in the middle of the night, you know, it's like 3 a.m. and this is the face of your website, and you're not particularly happy, and neither are your customers. So the way that it used to work, certainly the way I used to fix these problems, I used to work as a consultant, so I ran a small web dev consultancy in the UK. That's what we used to do, just open a bunch of shells and connect to the relevant servers, and you sort of guess what might be wrong, and you go there and you try to fix it. But the guessing itself takes time. So after a long session, you're like, God, I really don't want to do this again. Right? I'm glad it's over. And this is the kind of when this repeats again and again and again over time, it has a bit of a human cost to it. You know, you can get pretty, let's say, skeptical of life in general. You know, pretty. It gets just really emotionally difficult to keep waking up. And another problem that I experienced personally was that with some of these problems, like they would come at 3 a.m. and I would fix them, and then they would come back again at like 7 or 8, and it was just ridiculous. This didn't happen very often, but when it did, it was just like, I feel like, you know, like a monkey just like hitting some, not understanding what's going on. I'm fixing the website, but then it's falling back down again. And I don't really understand what is the root cause of this problem. Even though I understand the symptoms and I can treat the symptoms. So, we're not going to have time for the entire setup from scratch, unfortunately, but I will show you what APM does. So APM is obviously a solution to that. So generally when you do monitoring, you have like a few choices. Right, you can do very basic monitoring, so most people will put like a CPU and a RAM monitor and a disk monitor on their servers. So what you're actually monitoring is the server. You can see, oh, the CPU is at 100%, oh, it's this process, I restart it, and everything is fine for a few hours, or a few weeks, until it falls down again. So that doesn't really tell you, you don't understand the root cause from that. But that is how a lot of people do web monitoring. That's the level that we're at. That's the level that my company was at. And until we started using application performance monitoring. We didn't use this in particular, but this is a free thing that you can download, like, you know, right now and use for free in your company, in your businesses. It doesn't matter what size of business, there's no paid license for it. You can just use it. Right, so APM, the difference between that and server monitoring is that you get a real deep insight into what's going on in your actual application, like down to the lines of code that are being executed. So, for example, that's a collection of errors. So this is super useful error analysis already. So there you go, we have 8,000 of that error, which is a page not found, and here's some kind of integrity error. So already, that's much more useful than looking at a log, right? Because it shows you the unique types of error. You're not just scrolling through millions of lines of text. And the other thing this is super useful for, just by virtue of having it, is federated error handling, so error analysis. What I mean by federated is you have like one server, which collects all this error information, and you can have 10 application servers or 100 application servers running your actual web app. And so you see it all in one place. Now you don't have to log into individual machines or into individual Docker containers to see what's going on. You just open one UI and you just see the errors. And there's various ways, you know, like you can filter the time and so on. So yeah, so like, you know, if you're actually, you can diagnose a live outage with this tool without having to log in and look at text files at all, right? Which is pretty good. The other cool thing about this is stack trace. So just get started. Like, how much time do I have? Sorry, how much time do I have? 15. Okay, cool. Right. It's really hard. We've planned everything and the live demo, and then oh yeah, I have half the time. So with this, you've got different transactions that this application, this demo application is performing. And let's have a look at one of them. So here what you can see is a performance screen. The blue line is the average. So on average, we answer user queries to 216 milliseconds. Now, the other two are the 95th percentile and the 99th percentile. What that means is, the way this works is this thing does transaction information sampling. So it analyzes, it takes a sample of the transaction and it analyzes how quickly they're being answered. What 95 and 99 mean is, like for 95, it means that 95% of the transactions were answered faster than that, and 5% were answered slower. And the orange line, 99% were answered faster than that, and so 1% was answered slower than that. So this is useful to understand like what sort of experience your users might be having. Because like before, what I used to do when the admins, you know, my clients said the website was slow, I would go on it myself and I would have a look. But I might hit, you know, like just if it's intermittent slowness, I might get a time where it's accidentally fast, you know, or where it's kind of medium slow. And so I don't see what users actually see. I don't see data, I see anecdotes. And this is about turning, you know, moving on from anecdotes about performance to data about performance. You see some other information like requests per minute. Response time distribution is also super useful. So what you see here is like how many requests were answered within that time. So 44,000 were answered within like 60 milliseconds or so. Then 38,000 were answered in about half a second. Right, so you can really kind of see how well your app is performing. And you can dig in from this kind of view, you can dig in further to see which part of the stack might be the problem. Because you see a problem like this, and without tools to analyze it on the application level, you're like, well, you know, God knows. It could be anything causing it. It could be Green Unicorn, and Unicorn if you use it. It could be Flask or Django itself. It could be my code. It could be a database connector. It could be database itself. Who knows? And so that's what you do here. So that's a transaction view. So you can see information about the entire transaction. That's a sample. So what response the server gave and all that. Which is handy to have it in one place when you're doing troubleshooting. But the more interesting part is this. So this is a span. This is like, basically think of it like a part of a transaction, an important part. So like a database query is one span, and the Python code that's running is probably going to be one span as well. So you can see here, in this particular case, the part that we're looking at took 77% of the time. And we spent 675 milliseconds in this part of the code specifically. You can see the entire stack trace, so everything. So this is the actual code that we run. As you can see, it's like a random sleep. Then further down, you can see the actual stack. So this is Django. You just see literally the Django code that executes. And that can be super useful for breaking out like which part is slow. I mean, is Django being slow, or is Unicorn being slow? Like what's happening?
And this is super cool. And it's the same for errors. You know, you see the line at which the error occurred right there in your browser, and it's just much easier. And then there is... There's another view that I want to show you. So, how many of you how many of you use something like this? Okay, right. Okay, cool. And how many of you know about Elastic's free APM? Or knew, obviously, before I told you. Okay. Good. Well, now you know. Right. There is another cool thing about this that I find is really nice, and I would have liked to have this when I was building like open science websites. It's background tasks. So usually with application performance monitoring, you focus on web requests and how slow they are. But here, specifically in APM, the Python support, you can track celery. So you can track how long your tasks take. That are, you know, like processing image thumbnails or like sending emails in the background, you know, those sorts of asynchronous tasks that you would farm out to Celery or Huey or another library like that. And you see how many of them have failed and how many of them have succeeded on average. And this is again how long they took. It's again similarly to the other one. It's counted as a transaction. It's really one task, so it just starts and ends. You know, that's your one transaction. And in here you can see it's sort of breaking down the various things that this task does. There is the Python code, but there is also but there's also, this is an Elasticsearch GET request, which it recognizes automatically, and this is a select, so the whole system that's running recognizes that that's a SQL select. And you can see the actual statement, as well as how long that took, which I think is pretty useful. Like I don't think it gives you an explain plan, but this by itself would have saved me a lot of guessing and a lot of work. And you can see where the statement was issued as well. So where in the Python code that statement originated, which is not always that easy to tell, depending on how we've coded your app. Alright, so we go back to... Remember, and I guess this is probably quite similar to the Celery part, so I'm going to spend very long here. Again, it's a breakdown, you can see the exact SQL. You can kind of even see what the program itself is doing. So clearly, you know, we're going to insert something, like this is some kind of bulk processing task. We're going to select a specific customer here, so we're finding them, and then we've started to bulk upload into this table. And so for each item, the SQL database is executing a select and insert and a couple more selects. And you can see the blue bars represent how long that's taking as part of the entire, as a percent of the entire transaction. Horizontal scrolling. Right, my plan was to actually show you how you can get this integrated so that with a live demo, so you can walk away knowing exactly how to do it. However, that's not possible, so that's, I'm going to have to think on my feet. What I will show you is how do you change language? Let's see. Yay! It's my years of Bulgarian multi-keyboarding have paid off. Alt and Shift is the best choice, I agree. Okay, excellent. So, I am just going to very quickly show you what you would need to do in reality to run this. I guess button stop. Yes. Pretty much speak technically Ukrainian now. Right, so you have your app, obviously, that is running. So the other components that you need are an APM server. So that's your monitoring server, so that's a Go server, it's written in Go, that just sits somewhere and it listens on a HTTP port and it receives connections from your application servers. So the way that works in the application server ones is you instrument your application by doing pretty much that. There is a line for there is a bit of Django configuration that you put in, and that will show you actually. So you say Elastic APM is one of the requirements, and this is on the client side. So the overall structure, not prepared for this, but I can point to the screen. The overall structure is an APM server, and actually, I wonder if this has a, yeah. I'm gonna full screen that, I don't want to risk it. Right, so I don't know if you can see this very well, but you don't need to. Basically, here you got a few Java bits, Node, Python, whatever, Ruby. Those are your clients. That's the actual application that's running. That's your business logic, right? In there, you have something that hooks inside that application, and without spending much time, it instruments it and it starts tracking all of that information that I just showed you. That's called the APM client. All right, so the Elastic APM client is inserted into the Ruby, the Python, etc. Right, so from then, that APM client, it sends its information to an APM server. The APM, just an HTTP port, so that's all you need, you know, like you would do any other kind of monitoring and centralized logging. That's the server that's written, you know. Like, the APM server then sends, it processes the information from the client and makes it into structured JSON format, and it sends it on to Elasticsearch for storage. Okay? And that's it. As far as recording information is concerned, that is everything. Then, and so far, all of this stuff is open source, like, you know, Apache 2 license or BSD license, a permissive license. Then, on top of that, you have the UI. That's the Kibana that we were just looking through. That's what you use to visualize. So you have client, you have server, you have Elasticsearch. And then, separately, at any time, you come into Kibana and you look at the data in Elasticsearch. So that's the whole architecture. So the Kibana UI is not open source, but it is free to use, including in commercial settings. So that's what I was referring to earlier. Right. So back to this. So you've seen. Excellent. Well, I can actually show you some useful stuff this time. All right. So we have the app. So as we were saying, so this is your app. Much better. Right, so this is your app. This is the APM server. The app is instrumented with the client, and the client is sending to the server. You don't actually, and this is really your live demo would have shined, you don't actually need all this stuff. You just run that command. Like that's literally APM server -e, and it works. It's fine. That's incredibly easy to get started with. But here they've, you know, for the demo, they've set up various extras. You have Elasticsearch. You can do this in Docker. You don't have to, and you have Kibana. Kibana can be run totally separately from all of that other stuff. So you know you don't have like a single point of failure there. So you can architect the infrastructure that records the information in whatever way you like, so it's more resilient, and the bit that allows you to view the information is totally separate. Which mostly helps save money, because you don't want to be running 8 of those. So now we've kind of talked about the general architecture, and you've seen the Docker Compose for this demo, and you've seen the requirements. We're going to have a quick look at what I was going to show you, which is how do you integrate this with Django? Because so far you've seen what it is. Hopefully you're kind of excited. Maybe you've had similar problems and you don't know how to solve them. And well, now you know. And so this will be, if you use it, if you like generally know Django, this will be very familiar to you. It's a standard Django settings file. And this is the magic line, LSKPM contrib Django. That turns on the hook, the APM client that hooks into your app. That's what inserts it in there. Well, it's one of the lines. And the other line is this one. And this should always be at the top of your middleware, because the earlier you start the tracing, the more information it's going to collect, right? So, yeah, that's pretty much it. Yeah, actually, that is it. So you have requirements txt, put in the requirement for a library, put it in installed apps in Django, put it in middleware. Like, it's 3 lines. And that's it. You just, like, of course, I can't show you now, but it literally takes me like 2 minutes to start the whole stack with the web app. Just go from Elasticsearch, Kibana, APM server, start the web app, and it's recording already. So that's it, I got 3 lines. And I guess I'm about to run out of time.
Now we have time for a few questions.
Yes, that's exactly what I was aiming for. So thank you all for listening to me and for bearing with the technical problems. I'll repeat the question. I think you first.
We have to need some credentials to your application. So it will not be 3 lines to get these credentials inside your code. Or maybe something like consoles.
Well, it depends on your architecture, right? So the question is, you might have some credentials to secure the whole thing. It depends on your architecture. Like if you are using, if you're hosting everything on a virtual private network, and that you connect to in some other way, where you have an entry point, where your admins are connecting with an SSH key, before you even view Kibana and all the stuff I was showing, then you might not need any authentication internally, because all the data just stays inside anyway. Like this is not user-facing stuff.
Okay, right. And you have experience with Datadog service?
With what?
Datadog.
Oh, with Datadog. I don't have personal experience with Datadog, no. I have used New Relic. And I have looked at Honeycomb as well, which is like a different way of thinking about it entirely. And I don't have experience with Datadog. It's, I guess, a comparable offering, but there will be differences. And I can't tell you what those are in Datadog. So.
Okay. Thank you.
For your authentication, yes, it does actually also support authentication in like various ways. So if you want to do that, you can. Yeah, sorry, go for it. We have quite a few. Okay. Yeah, go ahead.
So,
sorry.
you mentioned New Relic, and it has such a clever feature like summarized breakdown for each transaction that shows like timings for example, database, Redis connection, external HTTP connection, and so on. And do you have such breakdown in your system, like to show some like summarized diagram for each transaction, for each like view, for example, in Django, to see what time we spend in database, in Redis, in external.
So what you saw, the timeline that you saw was that. So you, in the timeline you have.
But I saw that it's a bit more detailed, but in New Relic, for example, it is very convenient when you see like timings in the whole. You see a Django view, and you see like how time is spent in database. And
okay, so some kind of a more of a summary view. No, I don't think at the moment that we have a summary view like that. But there are other features that I don't have time to show. So I guess when you get to those, you would probably have that, because if you're doing distributed tracing, which I didn't show here, which we are, well, actually distributed tracing was just released. So we do have support for that. And in the UI for that, you will have tooling that's more like a summary, because then it's very hard. You know, you're not looking at individual parts anymore. So yes. So
One last question. And then
one last option. Anyway, you're very enthusiastic. Go for it. Sorry. Okay, that's fine. Alright, so yeah.
Is there another option instead of using HTTP, can you use VDM or something like that?
Instead of using what?
HTTP protocol.
Right.
Can you use another one, like VDM or VDM?
Oh, right, okay. I think it's a TCP/IP connection. That's a good question.
Yeah, because
I'll have a look. I think after the talk we'll go have a look at the code. It's open source. So.
Thank you very much.
Right. Thank you.